Alright, so for our next setup, we have a 300 gram or 0.3 kilogram air cart sitting on an air track, which is turned on, so we don't have any friction. And Nick, tell us what forces would be acting on the air cart right now.
There's a tension going left and a tension going right.
Okay, so there's a tension going to the right and a tension going to the left. And do we have any vertical forces going on there, Nick? We don't have any vertical forces going on there. Are we in a gravity-free room? All right, so we have gravity or weight going which way, Nick?
Gravity's going down.
Good. And technically, then we have a lift force going up from the air on the air track, but we'll just pretend that's a normal force for this. All right, so Nick is going to read off the tension that is to my right and Nick's left on the Brown scale there. So what do you see there, Nick?
4 newtons.
4 newtons. Thank you very much. And for this problem, what we'll do is figure out the tension that should be on the green scale. Alright guys, so for this problem we had a 300 gram air cart, so that would be 0.3 kilogram air cart sitting on an air track. And so once again we have weight going down. And we decided just to call it a normal force going up, but technically the bottom of that cart's not touching the air track while the air is turned on, but we're just going to call it a normal force. We could have also called it a lift force. We also had a tension going to the right, which Nick read off to us as being 4 newtons. And we also have another tension going to the left, which is what we are going to solve for. So in this problem, we do have both vertical and horizontal forces. We know that the net force in the y direction has to equal 0, which means that N is going to have to equal mg. And both of those would just be 0.3 times 9.8. So it turns out that both the normal and the weight for this problem are going to be about 3 newtons. If we just make that 9.8 a 10, it comes out to 3 newtons. But the question was, what is T2? So let's look at our net forces in our x direction. Those also have to equal 0 because our cart's not moving. And so what then that tells me is that the force to the right, T1, has to equal the force to the left, T2. So if we go over there and measure that second spring scale on the left, we should see that it's also 4 newtons. So let's see what Nick tells us about that. Okay, and so we have calculated the tension that should be on the green scale, and Mr. Crowder, can you read that for us?
4 newtons.
4 newtons, thank you very much. Alright, so once again there, physics works, and we see that the other tension is 4 newtons, and since we have a tension of 4 newtons to the right and 4 newtons to the left, we have an object in equilibrium.